Have you ever driven over a massive bridge and wondered, how does that even stay up? This video pulls back the curtain on one of the most stunning engineering feats, cable-stayed bridges. Discover the hidden science and genius behind these modern marvels that defy gravity and span vast distances. Welcome to Civil Engineering Edge, where we transform complex engineering wonders into simple, engaging insights. Today, we read diving into the fascinating world of cable-stayed bridges, structures that are not only architectural masterpieces, but also engineering marvels. From their graceful designs to the powerful forces working behind the scenes, you'll uncover how these bridges combine art, science, and technology to reshape our skylines. Architectural icons and their hidden strengths, cable-stayed bridges are among the most iconic structures in modern civil engineering. Their elegant profiles, marked by soaring towers and fan-like cables, make them landmarks across the globe. But beyond their beauty lies hidden strength. Unlike suspension bridges that rely on massive anchorages and continuous cables, cable-stayed bridges employ direct connections between deck and towers. This unique system not only reduces the need for extensive anchorage, but also allows for greater efficiency in distributing loads. Each cable transfers weight directly to the tower, which then channels it down into the foundation. This efficiency means cable-stayed bridges can span remarkable distances while using less material compared to traditional designs. From the Millau Viaduct in France to the Sutong Bridge in China, these structures symbolize human ambition, merging aesthetic appeal with practicality. Their design is a perfect harmony of form and function, making them both resilient and visually stunning. The ingenious cable system unveiled. At the heart of a cable-stayed bridge lies its ingenious cable system and arrangement that balances both gravity and motion. The cables, often made of high-strength steel strands, act like tension members pulling the deck upwards while pushing forces into the supporting towers. Unlike suspension bridges, which use a continuous cable draped over towers, cable-stayed bridges use straight, inclined cables attached directly from the deck to the towers. Two primary configurations dominate the design: fan-shaped and harp-shaped. In the fan arrangement, cables spread out from a single point at the tower top, resembling a handheld fan. In the harp arrangement, cables run parallel, creating a harp-like visual symmetry. Both styles have structural and aesthetic advantages, depending on site conditions and span requirements. The number of cables is carefully calculated, not just for supporting static loads, but also for resisting dynamic forces such as wind, traffic vibrations, and even earthquakes. Modern engineering uses advanced computer simulations to fine-tune cable placement, ensuring perfect balance between flexibility and stiffness. Beyond structural mechanics, these cables are coated with corrosion-resistant materials and monitored using sensors to track their health in real time. This integration of smart technology allows engineers to detect strain, fatigue, or anomalies long before they become threats. In short, the cable system is both the backbone and the signature of cable-stayed bridges, delivering strength, elegance, and cutting-edge innovation in one streamlined form. Anchoring the marvel, towers, and foundations. If cables are the veins of the bridge, the towers and foundations are its beating heart. Towers act as the primary load-bearing structures, absorbing immense tension from the cables and transferring it downward. Their design must account for not only vertical loads, but also lateral forces from wind, seismic activity, and even ship impacts in water crossings. These towers can soar hundreds of meters high and are usually constructed from reinforced concrete or steel, offering both durability and rigidity. Their geometry often is shaped, H-shaped, or single pylon directly influences how forces are distributed across the bridge. Beneath these towering giants lies an equally critical foundation. Whether built on solid rock, deep piles, or caissons sunk into riverbeds, the foundation ensures stability. In fact, the unseen foundation work is often more challenging than the visible towers, requiring extensive geotechnical analysis, underwater construction, and precision engineering. Together, the towers and foundations form the core structural spine of the bridge. They ensure that the graceful sweep of cables and deck above is not only visually breathtaking, but also firmly rooted in safety and stability. Construction feats. Building the unbuildable. Constructing a cable-stayed bridge is nothing short of an engineering spectacle. It often begins with building the towering pylons, which rise like sentinels above the landscape. Once the towers are complete, deck construction begins in segments, usually through a method called cantilever construction. Here, deck segments are cast or lifted into place one at a time, each supported by new cables added progressively. This balanced cantilever method is essential, as one segment is built on one side of the tower, a matching segment is built on the other, ensuring equilibrium at every stage. Without this balance, the structure could collapse during construction. One of the biggest feats is working in challenging environments. Engineers construct over wide rivers, busy shipping lanes, and deep valleys, often battling weather, water currents, and logistical constraints. Specialized floating cranes, temporary supports, and precision cable tensioning equipment are used to keep construction safe and precise. Modern technology, such as GPS monitoring, drones, and advanced surveying tools, ensures millimeter-level accuracy in aligning cables and deck sections. What appears as a graceful final structure is actually the result of painstaking planning, coordination, and innovation. Each completed cable-stayed bridge is a testament to human ingenuity turning what once seemed unbuildable into a proud reality. The future of sky-high innovation. The evolution of cable-stayed bridges is far from over. With rapid advancements in materials, design software, and construction technology, the future promises even more breathtaking spans. Engineers are experimenting with ultra-high-performance concrete, carbon fiber-reinforced cables, and self-healing materials, making bridges lighter, stronger, and longer-lasting. Digital twin technology creating virtual replicas of real structures is revolutionizing maintenance. Engineers can now simulate stresses, monitor cable health in real time, and predict potential failures before they occur. This ensures not just safety, but also cost efficiency and long-term maintenance. Sustainability is also shaping the future of these giants. Designs now incorporate energy-efficient lighting, solar panels, and even wind turbines integrated into towers. By blending renewable energy with infrastructure, bridges can become self-sufficient energy producers. Mega projects are already pushing boundaries. Countries are competing to build record-breaking spans that connect cities, shorten trade routes, and redefine skylines. Future cable-stayed bridges may stretch farther than ever, supported by lightweight yet ultra-strong materials that minimize environmental impact. In short, tomorrow's cable-stayed bridges won't just be transport solutions. They'll be symbols of sustainability, innovation, and global connectivity. They will stand as proof that engineering continues to push the limits of imagination and possibility. And there you have it, the secret world behind cable-stayed bridges revealed. From their iconic towers to their ingenious cable systems, these structures embody the perfect blend of beauty and engineering brilliance. They remind us that with creativity, precision, and ambition, humans can turn challenges into marvels that redefine our landscapes. If you enjoyed this deep dive into engineering wonders, don't forget to like, share, and subscribe to Civil Engineering Edge for more fascinating explorations. Together, let us continue unraveling the mysteries of modern infrastructure and celebrate the genius that holds our world together.